on the scene. He's got the voice that's mean, asking those questions that you never seen. He's got that fire, burning bright and clean. Andrew Keen making waves, break the routine on the Keen on show. He brings the heat, asking the minds, digging deep till they bleed. No sugar-coated truths, no lies to deceive. Andrew Keen, the master of the interview beat. He's got the knowledge, he's got the flair, challenging ideas with a fearless stare. With every question, he's uncovering what's there. Andrew Keen, a truth seeker, he's aware.
Hello, everybody. It is October the 10th, 2024, a Thursday. It's been quite a week when it comes to technology. Beginning of the week, the Nobel Prize for Physics was awarded to two pioneering AI researchers, including Geoffrey Hinton, who used to work at Google and now has become a critic of AI. And then yesterday, the Nobel Prize for Chemistry has gone to three scientists for predicting and creating proteins, including, as it happens, two scientists at Google from DeepMind, Demis Hassabis and John M. Jumper. I think what both these awards suggest is that these new technologies, the technologies of the 21st century, are profoundly changing the world. They're not just theory, they're practice. One man who's all too familiar with many new technologies is our guest today, Neal Baer, or Neal Baer, not Bauer. It sounds like Bauer, B-A-E-R, but pronounced Baer. Is a trained doctor at Harvard, from Harvard Medical School, but he's also a man who is very much involved with the entertainment business. He's the showrunner for Designated Survivor, ER, and Law and Order. And he's the editor of a new book called The Promise and Peril of CRISPR. He's joining us from Boston, Massachusetts. Neal, do you share my sense that we're at the beginnings of something really profound when it comes to these new technologies? We're going to, of course, talk about CRISPR for the most part in this show, but more broadly, this age of AI and all these other profoundly transformative technologies.
Oh, definitely. And they're not predictable, even though we try to figure out what they're going to lead us to. But just like other technologies like fossil fuels, the invention of plastics, nuclear energy, they were all touted as being, the saviors of modern life. And ultimately, there have been a lot of problems with all three of those. And so I don't know that it was predictable. Would be, and and nuclear energy has had its ups and downs, of course, and not as popular as it once was after Chernobyl and 3 Mile Island. So I think we can predict, but we just don't know the future of AI, and we don't know the future of CRISPR. We know how they work, but to predict the outcomes, I think, is not necessarily wise. That doesn't mean that we shouldn't be careful and have very strong conversations about how we're going to use these technologies.
Neal, you're in an interesting place. You're not a hard scientist, although, as I said earlier, you have a medical degree from Harvard. You also teach at the medical school. You're best known, as I said, as the showrunner for very successful television series like Designated Survivor, ER, and Law and Order. But you bring a particular scientific sensibility. I'm guessing to the medical or the scientific profession, they're probably a bit suspicious of you, and the entertainment people probably feel a little uncomfortable around you. How have you got to this point? Most people who go to Harvard Med School end up as doctors, and most people in Hollywood specialize in fiction. How have you walked this fine line between science and entertainment?
Well, I've always been interested in both. And so it's the ideal working situation career for me. I don't know that the medical side is suspicious per se, because at least with ER, we were really careful in the leaders in bringing accuracy to medical shows on TV. I was involved in the start of a organization called Hollywood Health and Society that's at University of Southern California, the Norman Lear Center. So the late Norman Lear funded it. And they provide, I'm on their board now, accurate information on health to any TV writers or movie writers in Hollywood. And fortunately, the networks demand that the work on their shows be accurate. So they do ask for data and support. And that's, I think, important. So yes, things happen much more quickly on shows like ER, but for the most part, we've tried to be as accurate as possible, because we published the first experimental study that looked at what people learned from medical series, and we were stunned to find out they learn a lot. And so we think it's important to be accurate. It's not just park your brain, outside and sit on the couch and watch a show and be entertained. We really want people to be able to trust what we're doing. But I think it's, and then, I think it's been really fun for me. I started out as a TV writer and then went to medical school thinking that's where I was going to end up. And in my 4th year, I received the script that Michael Crichton wrote for ER about 25 years before. And Steven Spielberg bought it to make it as a movie. And then it lay dormant literally in a trunk in his office for 25 years. Someone found it and Steven said, oh, maybe we should do this as a TV series. And NBC did not like it. They thought there were too many storylines. It was too much about the doctors, but they were proven wrong when the show aired. And it was probably the most popular network series in the last 30 years. In year 2, I did an episode with George Clooney where he saves a kid in a tunnel that I wrote called Hell and High Water. We had 48 million viewers. That would never happen today. There are too many.
It's quite, Neal, it's quite a responsibility. I mean, obviously, everyone would, I wish we had 48 viewers, let alone 48 million viewers for this show. But does it come with a kind of moral responsibility for you as having one foot in the medical scientific community, another in the entertainment business, to represent science responsibly, ethically to a non-scientific audience?
Oh, absolutely. I feel that way. As I said, I don't feel it's just we should tell anything that comes to mind about science. My favorite line ever in a show is on Law and Order Special Victims Unit that I did. And it's about a mother who doesn't vaccinate her child. And he goes to the park. He's 5 years old. And it turns out he has measles, which is very, very contagious, more so than COVID. And he infects a little girl who's under a year old who was at the park. And that little girl dies of complications. And so I raised the question in the show, whose responsibility is it? Is it just, too bad for that little girl? Or did that mother have a responsibility not only to her own child, but to the community of children? And that's what we raised on the show. And when the mother is on the stand for involuntary manslaughter, because, it is a show and I could put her on trial, she says that contrary to what physicians say, who are experts, pediatricians on taking care of children, that for her, science is just another opinion. So that's what we're dealing with today. A lot of science is just another opinion. And I really like that line, because I think that's the tragedy of where we are now. People dying of polio and measles complications, COVID, because they haven't been vaccinated and they know best. Science is somehow a conspiracy now. Science is just another opinion. And, we can throw out experimentation and the whole foundation of science, because if you have a different opinion, that's fine. So I do feel we have a moral and ethical responsibility to be as accurate as possible. We go to so much trouble to make our shows look real. Like, why, why do we just not do it in front of a cardboard backdrop? Why do we make the hospital look real? Why do we put them in real scrubs? Why do we use real instruments? Why do we make the blood look real? Why? Because we want people to be transported into that and feel it's real. And if we're going to do that, I think it's incumbent on us to make sure that the information is accurate. And that's where Hollywood Health and Society comes in, to ensure that writers have access to accurate, empirically based information.
Neal, is it coincidental that, and you've already talked about this, that at a time of increasingly sophisticated technology, we're going to come to CRISPR in a minute, AI, biotech, of many different things. You live in Boston, where you divide your time between Boston and Paris. Boston, of course, being the center of biotech, MIT, Harvard, Northeastern. That in this age of ever increasing and revolutionary science, which is very hard for non-scientists to understand, we also live in an age of, as you suggested, populism, where people don't even, I mean, it's not that they don't trust science, they don't even understand science. Are these two phenomena connected, or are they separate? Are they in parallel?
I think it's both. I think one of the problems is that people want to trust science. So we see this interesting situation with COVID, which was, tell us what to do when COVID first appeared. But science is not cemented in one place at what, it is always evolving. And so if we talk about, say, measles again, we know an awful lot about measles. We know what it can do. We know how contagious it is. We've had the experience of working with measles for many, 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 years, and making the vaccine. COVID was a novel virus, so we didn't have the information. So what we said at first, like, maybe you need masks, maybe you don't. And as it evolved, that we were learning more about it, of course, we had to change what we were saying, because we were learning more, because science is accruing information through experimentation and through observation. And so I think this is really tough for people. They want definitive answers about COVID. We still don't have definitive answers about COVID and long COVID and what causes it. And so that makes it, well, science then isn't really like helpful, because we don't have the answers. But the answers take a long time. We don't have answers for cancer, for all kinds of cancer. Certain cancers we have answers for. Cervical cancer we know is preventable if you get a vaccination, Gardasil. 3 vaccinations of Gardasil. So we know that. Still people don't do it. Still people get cervical cancer. So it's about trust, and it's about understanding, because I think people feel science is too complicated. Though, I think we could do a much better job in schools, from preschool forward, teaching science. Science is really fun. Science is amazing. Science is about curiosity. Science is about understanding how things work. And it's also about, it is about trust, but it's not blind trust. It's understanding the scientific method. So, anecdotes are not the scientific method. Yes, you can find people who will say, and they really truly believe that their children have autism or problems after they've been vaccinated. And we do know that some kids do have side effects, and some very serious side effects. But in the population, it's very rare. And so it doesn't matter that we have the data. People believe what they want to believe, and this is what's really troubling. And yet, even if they don't get vaccinated for COVID, how many people who are anti-vaccination will still go to their doctor because they have diabetes. Will they take insulin or will they not? I think they take insulin, you know, but insulin has been around for 100 years. We know a lot about insulin. We know a lot about type 1 and type 2 diabetes. So this is where, you know, there's, you know, a lot of really complicated things going on where COVID and COVID vaccination is tied into politics. Type 2 diabetes, not so much, except for the cost, because it was so expensive. And so I think it's almost like we need a redo starting in preschool to really work with kids and adolescents and college students and graduate students on understanding science. But not everybody goes to college or graduate school, but everybody goes to school. So I think we have to really think harder. It's almost like the space race, you know.
Everyone, of course, watches television. Let's get to your new edited book, The Promise and Peril of CRISPR. Before we get to its promise and peril, a lot of people have seen this term, CRISPR. What does it mean, Neal, and how profound is it? You've dedicated some time towards editing this volume. It's a Johns Hopkins book. Johns Hopkins is a leading medical university. What is CRISPR, and why is it such a big deal in your view?
Well, CRISPR is an acronym for a long term, which is essentially editing out amino acids that make up DNA. So if you think about typing on your computer and you spell table, T-A-B-E-L, you might have autocorrect, which will correct it. But before we had autocorrect, you could take your cursor and back up and change the EL to LE. So you were homing in on the mistake and then editing it and making it correct. Well, that's what CRISPR does. It is a tool that has enzymes, and it homes in on the mistake, the mutation, let's say, for something like sickle cell disease or other diseases. And it cuts out, like scissors, snipping out the piece of the gene that has the mistake, the mutation, and then it pastes in the correct sequence. So you can imagine that there are many diseases that have maybe a mistake of one letter that causes terrible, terrible disease. We could go in with CRISPR, home in on that mistake, cut it out, and put in the correct version. That person is. That's in a sense what's happening with some fairly rare diseases that are very, very terrible. Beta thalassemia, a hemoglobin disease, and sickle cell anemia as well.
So, Neal, let's step back a little bit. Are you suggesting that this gene editing takes place before birth or after birth? How exactly does it work?
Well, there are two different ways. One is before birth and one is after. So let's talk about the after. That's called somatic gene editing. So someone who has sickle cell disease, sickle cell anemia, they would go and get treated, and CRISPR would turn on a gene that's been turned off after we're born. Before we're born, we have what's called fetal hemoglobin, which really attaches to the oxygen in our mother's blood. It turns off. We don't need it when we're born. And then we have our normal hemoglobin. Well, that hemoglobin is not, that blood is not normal for people with sickle cell disease, and they end up having strokes when they're children. The red blood cells sickle, they curve, and they get caught in joints, horrible pain, and they get caught in arteries, causing strokes. So we can address that with CRISPR by injecting the blood. And it's a very complex process. You have to be in the hospital for an extended period of time, but there are people who've been cured. And this is a miracle. So that's called somatic. It doesn't change their cells, their reproductive cells. The other, before birth, as you asked, is called germline editing. And this is where there's more controversy.
This is less on the promise and more on the peril of CRISPR.
Correct. So there was a doctor, geneticist in China named Dr. He, who experimented on an embryo that was fertilized. And he used CRISPR to mutate. He knew the gene for the receptor for HIV, the cell, the receptor cell. And he mutated it using CRISPR to go in and change that. And the embryo split into twins, and they were born. And this caused huge uproar. There's also a third child, we believe, who was born using CRISPR. So what happened is he changed the embryo before it was born. So that means that those now girls, if they have babies, they will have who have their babies would also have the mutated receptor. It would be passed on. Somebody who gets CRISPR'd for sickle cell can't pass it on because it's not in their germline active cells. It's in the cells in their body. So, okay, when would we need to do this? Well, there is a Russian scientist, geneticist, who said that he wants to do this kind of embryo editing for parents who are both deaf, who have no possibility of having a child who can hear. So he wants to change the gene that causes their deafness in the embryo. That's a very rare circumstance, and that's one of the few reasons to maybe do CRISPR.
So essentially scientists are becoming, theoretically at least, this is the peril or the controversy, is you're turning scientists or gene editors into gods. They're deciding not just whether or not life should exist, but what form it should have. Is that fair?
I think in the future, I think it's difficult now. Well, first of all, it's illegal to do it, but that doesn't mean that people won't, because, you know, people aren't supposed to jaywalk and they jaywalk. I mean, people do things that are illegal.
Yeah, but jaywalking is something that police rarely waste their time with.
But even people do, you know, one knows of maybe political figures who break laws. So it's like,
whoa, I haven't heard of that, Neal.
So it's one thing to make a child. There are people in the deaf community who would argue that deafness is not a disease or a pathology. It is just human variation. That's in our book too. But I think more importantly, as we understand the genome better, we get into questions of enhancement. Like, what if we want to make our child pain-free? Well, there are some mutations that cause people not to feel pain. What if we want our child to, and supposedly Russia and China are doing research on making soldiers who don't feel pain, who don't have to sleep as much, who don't have fear. As we learn more and more about our genome, it's possible that people who can afford it will enhance their future progeny, and those who can't will not. And so I think before that happens, you know, our genome is complicated, so complex in the sense that even our eye color is not, you know, controlled by one gene. So our musculature and our whatever intelligence is not one gene. But we learn more and more, like, as I was saying, like about pain. We could.
So we are sort of infinitely plastic. I know you were working on a genetic thriller drama, The Edit. Is that whatever happened to that project?
You know, like many projects in Hollywood, it takes years to get things going. And so, you know, and that was before people really knew about CRISPR. But have you heard a politician ever talk about CRISPR? No. And so they're talking about AI, but it's because people don't really know about CRISPR yet. But it's going to come. And it's not just people, you can go online and order CRISPR kits and make giant tree frogs, and you can make yeast that is used to ferment beer.
Is this
Well,
chilling, Neil, or is this exciting, or both?
well, it's both, because we can cure diseases and we're going to be able to cure more. And I think that's great to alleviate suffering. But that's not passing the gene on. That's not controlling human evolution. Just think, if you can control embryos, if you can change embryos, you have the ability to change evolution, which takes millions of years in, in a matter of, a few years or 9 months. So you could start doing things that evolution was responsible in the past. We do it with animals, of course. We've been doing hybrids and domesticating animals and plants for millennia. So in a sense, we've been doing CRISPR, in a way, but not in a way that's so predictable and so precise.
I mean, this is definitely, and you don't need me to tell you this, science fictional. The idea of Russia or China or the United States, for that matter, gene editing soldiers so they don't feel fear. I know you deal with some more, maybe more realistic scenarios. You've given some thought to the issue of disability. One figure who's been very influential in this thought in this field is Rosemary Garland Thompson. She had an interesting op-ed from the New York Times in 2016. Is disability, which is increasingly a political issue, is it something that CRISPR can and should get rid of?
Well, that's the question, isn't it? We have a number of pieces in our book, one by Weiss, who is a cardiologist in San Francisco, and he has a child with albinism, which is a mutation. And he said that in his piece, if he and his wife had known that their child would be born with albinism, they might very well have aborted the fetus. But now that they have her, they would never want to do that, because she has brought so much joy to their lives, and she has a very robust life herself. But how do we know what's going to be, until it happens? And that's a really important question that Rosemary Garland Thompson raises, and Ethan Weiss raises, and others in our book, that, one person's disability is another person's aborted fetus. So,
and again, it's probably no coincidence that the issue of abortion now is so controversial. Another of the people who's been very prominent in this is your Harvard colleague, George Church, a geneticist, who is a defender of gene editing babies. What does Church say? Do you agree with him?
No, but because he says that we should gene edit babies because it's, I believe what he says is that it's ultimately less expensive to treat sickle cell disease, let's say, when they've suffered for a number of years. Why not just gene edit every embryo and get rid of all of these genetic diseases before the child is born? So that is, I think, for me, not the way to go, because, as I just said, it's a slippery slope. What are we editing out? This is what Rosemary Garland Thompson calls velvet eugenics. It's like, is there like some ideal that we're trying to make all children be? What about Down syndrome? What about, there are certain genetic diseases that are terrible, and not curable and fatal, like Tay-Sachs or adrenoleukodystrophy. I don't think that anyone would disagree. I mean, maybe if some people would and say it's God's will, but would want a child to suffer like that and then die for sure.
Yeah, I mean, doesn't it depend on one's moral philosophy? I know you've said And you were quoted in an interesting Live Science piece from August of this year. Who are we to say they shouldn't exist? But if you're a Catholic, you have one position. If you're a hardcore Benthamite utilitarian who believes in maximizing pleasure and minimizing pain, you have quite another. So doesn't it ultimately depend on one's operating philosophy, Neal?
Well, yes and no. It's, you know, does that mean that we should weed out people? Now, just to go back for one moment to George Church's position, we don't need CRISPR to make decisions about you know, embryos. We have something called, we have to go in and CRISPR embryos, except for the deafness. So let me clarify this. We have something called PGD, pre-implantation genetic diagnosis. So if a family knows that they carry Tay-Sachs or adrenoleukodystrophy or Marfan's or, you know, thousands of different genetic diseases, we can look at the embryo that's fertilized and we can implant only those that don't carry the mutation. So we don't need CRISPR to fix things. We just have to go through IVF. The person has to go through IVF in order to have the egg, and then we separate things out. But if they're deaf and they have the same genetic mutation, then their child will be born deaf, and there's nothing they can do about it. PGD won't work because every single embryo will carry that genetic mutation. That would be, some people argue, a time to use CRISPR. I just worry that with George Church saying these, you know, that he would do this, that he's talking about the cost. Like, why spend all this money treating people when we can just get rid of these diseases? Now, a lot of diseases are there for evolutionary reasons, like sickle cell disease. If you're a carrier, so that means you have only one copy of it, then it's been found that you are more resistant to malaria. So evolution played a role in making sickle cell disease, to make people resistant or more resistant to malaria. If you're unfortunate and get a copy of the mutation from both your mother and father, then you're going to have sickle cell disease and you will likely die much earlier than most people. That's the consequence of evolution. More people survive malaria, but some people pay the price for that survival.
Neal, these are complicated issues. You obviously recognize this in your new book, The Promise and Peril of CRISPR, but someone ultimately needs to make the call. It's like with AI. Should we allow technology that essentially makes machines smart or potentially smarter than humans? Is the medical community or is the government ready for the CRISPR revolution? Does that worry you? Is that one of the perils?
It is a peril, and it's the last essay in our book by Ben Hurlbut from Arizona State University, who talks about how ethics often follow scientific discoveries. So in 2015, there was agreement amongst scientific organizations to not do germline editing. Once Dr. Hood did it, that changed, and scientists started saying, well, maybe there are times when we can do it. So in other words, instead of having the ethics and the discussion, something happened, meaning Dr. Hood did it. So then it was like, it's been done, let's move forward. Now maybe we'll do it with deaf parents and their offspring, and then we'll move forward again. And so we have this problem, this peril of moving forward without thinking about the consequences because we can do it. And so I think it's really important, not just for doctors or for scientists or for politicians to think about this, but for everyone too. And then how do we do that? And that's the, you know, biggest challenge. How do we do it? Well, we have to talk about it in school. We have to do science, better teaching of science in school. We have to talk about it in ways you know, in the arts, that is one way we learn about things. And so that's why I'm a television writer. And that's why my program at Harvard, my master's degree program that I created in media, medicine, and health, is about looking at how the arts and humanities can help us understand science, particularly health science and medicine. So I don't think it's up to just doctors to decide, because I've had scientists, geneticists tell me that they should be allowed over, that they know what's best. Well, how do they know what's best? I mean, they think they may know what's best, or they think they can oversee and keep people in line from doing, you know, making bioweapons or using CRISPR in nefarious ways. And not even laws may do what we need them to do, but we don't even have oversight of who can buy the pieces that scientists and geneticists need to do CRISPR. Companies that be aware of who's buying what. So for instance, if someone is buying something that looks a lot like the structure of pox, then they can inform someone, or they can prevent them from getting it. But we just don't even have in place. We have rules, we have laws that say you can't clone people, and you can't edit, you know, an embryo. But that didn't stop Dr. Hu from doing it.
Neal, you mentioned earlier that one of the contributors to the book suggested that technology somehow trails culture. And it seems to trail politics. A lot of the things you're talking about are being discussed, maybe implicitly, politically, about sexual identity, gendered identity. Your 2016, you were quite public in coming out as a gay man. How much could that impact? How much could CRISPR technology impact this debate? I mean, there are conservatives in America today who believe that perhaps this technology could be used to, a J.D. Vance-like figure might suggest that this technology should be used to create straight Americans who can have children. So are we close to a Handmaid's Tale dystopia here?
Yes, but not for CRISPR. I'll get to that in one moment. We do have, I think, the first piece by a trans bioethicist, Florence Ashley, who talks about CRISPR and
this is in the book, in Promise and Peril.
Yeah. The thing is that there's no gene for gayness. There's no gene for transness. There may be certain what we call polymorphisms that are more common in trans people, or maybe more common in gay people, that could be manipulated, which I worry about, because who's doing the manipulating and for why? Why can't we accept who we are? That gets back to your first question about people with disabilities, like what's acceptable, what's not. A lot of disabled people say, I don't want to be fixed. I don't see myself as disabled. The other coming down the pike in terms of technology is a technique called IVG. Have you heard of IVG?
No.
So that's in vitro gametogenesis. So what is that? Some Japanese scientists working with mice took some stem cells, what we call pluripotent stem cells. These are stem cells that can become the different things that make us up. And they coaxed them to become sperm or eggs. So ultimately, what does that mean? It means that we might not need men because we could make a sperm cell from a woman, from a stem cell. Or two men could have a baby by one of them donating his sperm, the other donating a pluripotent stem cell that could be coaxed into being an egg. They'd still need a woman to carry the baby because we don't have uteruses that can carry a baby outside the mother yet. But you could implant an egg conceivably that is from two fathers. So I could imagine that a gay couple would want to be both biological parents. You could use CRISPR conceivably, you could have two men and you could have the egg donated by the woman and the sperm donated by the father, and then go in and you could CRISPR some of the other man's genes into that baby. So
it's again, more science fiction. Final question, Neal. It's a very interesting subject. People have been talking about AI for centuries. It only seems to have become real in the last 10 years, maybe since the development of LLMs by OpenAI. Where are we broadly in historical terms in terms of the history of CRISPR?
Well,
is it oven ready, so to speak? Or are we still at a moment where the equivalent of Google or OpenAI or one of these other revolutionary new technologies or companies are going to make it really central in how we live, how we operate?
Well, we've been talking about CRISPR. We haven't called it that for many, many years. The island of Dr. Moreau is really about kind of CRISPRing animal humans. And we do talk about transhumanism and we do take human genes and put them into animals to make organs and pigs and things like that. We're doing that now. We have an essay in our book about what we should or shouldn't do to animals. So I think CRISPR is said to treat some very terrible diseases. It's very expensive. There are 100,000 Black Americans with sickle cell disease in the United States. It costs $1.6 million in their lifetime on average to treat them, usually by insurance or Medicare. Their life expectancy is much shorter than average, in the early 40s, and they suffer from terrible diseases in childhood, strokes, things like that. It also costs between about $2.5 and $3 million to do it right now, to use CRISPR to treat sickle cell disease. So who's going to pay for that? There are 8 million Black individuals around the world. They're mostly Black who have sickle cell disease. Who's going to treat them? Who's going to pay for it? And so these are other ethical questions. Yes, we can do all these things, but they come at a cost, a financial cost that is not really possible for people to afford. Will insurance companies pay for it? So these are like today's questions about CRISPR, because it is ready. We can treat people, we can cure them. Who's going to pay for it? Should we pay for it? Should the government pay for it? I think the government should, because I think healthcare is a human right. But as we develop more and more of these treatments, it's going to be expensive. Personalized medicine, it's going to be expensive. Are we going to have those who can have it, the enhanced and the normal? As Michael Sandel wrote in 2004, around that time in Atlantic, predicting what was going to happen.